Hello everyone and welcome to the session on SQL Server TempDB architecture. TempDB is the one of the most important system databases in SQL Server, but also one of the most misunderstood. Think of a TempDB as a SQL Server scratchpad, a temporary workspace that the engine uses to handle all sorts of operations. Whether you are storing a data, sorting a data, creating a temporary tables, or running queries that need intermediate storage, TempDB is always in action. In this video, we will cover what TempDB is and why it is important, its architecture and components, real-time use cases with examples, best practices and common mistakes, monitoring and configuration tips. Coming to this, what is TempDB? TempDB is a system database that automatically created every time SQL Server starts. Here is the key point. TempDB is recreated fresh on each restart. That means nothing persists in it. It's like a whiteboard that gets wiped clean whenever SQL Server restarts. Imagine you are doing math on a rough notebook while preparing for an exam. That rough note is not your final exam paper sheet. It's just for a calculations and quick notes. TempDB is SQL Server's rough notebooks. It stores temporary tables like hash temp, hash, global temp, etc. Table variables, sortings operations like order by, row versioning for snapshot isolation, DBCC operations, and index rebuilds. So, whenever you run queries that need intermediate space, TempDB silently kicks in. Coming to the TempDB architecture. Now, we are looking into the how TempDB is structured. TempDB consists of data files and a transaction log files. The primary data file is the main data file and secondary data files is for performance and parallelism. Transaction log file or LDF records changes just like in a user database, but it resets on restarts. For the best practice, number of database data files equal to number of CPU cores up to 8. Maximum of 8 CPU files you can keep. For example, if your server is 2 CPU cores, so then you need to allocate 2 data files, MDF1 and NDF1. If it is 12 or 16, maximum of 8. This helps avoid contention and spreads out the workload eventually. Think of it as a supermarket billing counters. If you have one counter, customers queue up. But if you open more counters, the load gets distributed and processing is faster. As discussed, we have data files, log files. So data files have multiple data files. One is primary and recommendation, and we have discussed about number of data files equal to number of CPU cores. And log file is for all the log gets records in log file, and it will be cleared during SQL Server restarts. And allocation, so TempDB uses round robin allocation systems across data files. It has extend allocation, mixed extents, and uniform extents. And we have already discussed about TempDB uses like temporary tables, table variables, common table expressions, sorting operations, joins and aggregation, index reveals, and row versioning while using snapshot isolation, online index operation, DBCC operation. For those all operation, it will use TempDB. So we are going into a practical example. Imagine we have a sales table with thousands of transactions. If we create temporary table for monthly sales summary. That table is stored in TempDB. If we declare a table variable for top customers, that also uses TempDB internally. If we use CTE with sorting, TempDB is used for sorting behind this. Let's see an example. Go to SSMS, go to our databases, new query. Yeah, creating sales one. Already sales exists. Create table, sorry, database. We have created table. Sales one under sales TV. Okay. Then we are inserting records four rows got affected. Now we are using, will be copy paste everything. So we are creating TempDB temporary table stored in TempDB. So we can change this to TempDB. So we are creating monthly, then go for monthly summary. uh, Example 2. We are going into three examples over here. One is for temporary table. So we are creating a temporary table in TempDB. So we have created temporary table called monthly summary. So it is completed. Insert into monthly summary from, we have given month, integer, year, total sales and total quantity. So select month will be a sale date as month. Year, for year we have given sale date as year. Sum amount as total sales. Sum of quantity equal to total quantity from sales, group by year and month. So like that we are inserting a record into monthly summary from sale one table on sales DB. So we are executing invalid object name sales one. We need to give um, Can create. Okay. And we are inserting. Okay, this is done. Select star from monthly summary so that it is done. And now going into example 2, table variable. You also uses TempDB. So declare top customers table. We are declaring and we are inserting top customers from sales one itself. Execute. Must declare the table variable at top. Okay, let's go into TempDB first. At done. Now we are going back to sales TV and now we are running this one. Okay. Okay. I think we not need to run both at a time. Yes. And now we are executing this. I think we need to run three. Let's see. Execute. Yeah. So we are using table variable. So due to that, we need to run three queries at a time so that you will get an output. Otherwise, it will ask to give. If you run only this, you need to declare at top customers like that. You will get an error. See, must declare the variable. So you need to run at a time three. First, we are declaring a table. Top customer is a table name, and we are inserting and we are getting the output. So we are using a third example using sorting method. So that also uses what? TempDB. Execute. We got 4 and at last we are dropping the table. That's it. This is how it will use the TempDB, which is for temporary purpose. So this is like a restaurant kitchen. Order comes in queries. The kitchen prepares intermediate dishes on the counter, which is TempDB. And finally, the finished plate goes to the customer, the final result. Without TempDB, SQL Server would struggle to prepare those intermediate steps. So coming to the TempDB best practices. TempDB performance can make or break your SQL Server performance. Here are the some best practices. So what we must do, use multiple data files equal to CPU cores. Keep all data files at the same size. Place TempDB on the fast SSD storage. Resize TempDB to avoid constant auto growth. Monitor TempDB space regularly and don't use only one data file which causes contention. Use percentage based growth leads to unpredictable sizes. Place TempDB on same drives as OS or user database. You should not do. Leave default small sizes. SQL Server workloads will choke. Think of it like a busy office printer. If only one tray has paper and it's small, printing slows down. But if you load multiple trays with equal paper, the printer runs smoothly without interruptions. So coming into the multiple data files, file configuration, and select, we are checking TempDB file configuration. Again, go to there So we have MDF, NDF, and LDF. It is correct. If we need additional database, then you need to run this command. And equal sizing. We need to keep all the TempDB data file in a same size. So coming to our thing, so we have given same size for both the data files. Then coming to performance optimization, set proper growth for TempDB files. So altering an initial size file growth will be 256 MB. So they are fixing 256 MB for each file growth, auto growth. Go to TempDB, right click, properties, files, and we have given 64 MB for all and unlimited size. So it will grow by 64 MB, 64 MB, and it will increase. So the three best practices has been successfully already we have done. Coming to the monitoring at TempDB. Here are some useful queries. Check how much space is used by objects, internal operations, and version store. So this is the query. Check how much it is used by objects, internal operations, and version store. So user objects, internal object, version store, and we have a free space as well. Then second one, we need to we are checking file level usage to see which file is filling up. Used total, so both are same. Still, there is no long running session, so we are unable to see which file is getting increased fast. Then we are going to check which session is consuming our MDB heavily. For that, we are running this one. So session 99 and session 54, which we are running, is user object allocation count is 32, deallocation internal objects, internal objects. So these queries help DBAs understand if TempDB is becoming a bottleneck. This 3-1. In a reporting application, if a developer writes a query with a huge order by on million of rows, TempDB can run out of space. By monitoring, you can catch such queries and tune them by using these three queries. So coming into the advanced configuration, in production, we often configure TempDB carefully. Set multiple NDF files on different disks. Free size files, example like 4 GB each. Set fixed growth increments like 512 MB instead of percentage. Ensure the log file is also sized properly. This prevents fragmentation and auto growth issues during peak hours. It's like planning a wedding hall. You prepare enough chairs and food in advance instead of waiting for guests to arrive and then scrambling. We already saw the do's and don'ts. And coming to the quiz, how many data files should TempDB typically have? Equal to CPU cores? Correct. To summarize, TempDB is SQL Server's scratchpad. It stores temporary objects, internal operations, and row versioning. Proper configurations and monitoring are key for performance. Real world workloads like reporting, ETL, and data warehousing rely heavily on MDB. Thank you.